Okay, I had a great question from a student who asked me this. She said, okay, when you do a function here, there's usually a return statement at the end of these statements. And I guess I want to say that this is the way that functions want to work, where there's a return type and there's a relationship between that return type, i.e. in this case a string, and then the return statement. So if you want for there to be a return value, like for example, if you want the function to figure something out for you and to return a solution, like what's the square root of 9? You're actually going to get a value back. And so the return statement kind of is required in order to pass compilation, in order to make it compile. So let me just do this real quick. And we're reaching a kind of a point of danger in this program because it is growing and it's harder to work with bigger programs. It's easier to work with a fresh program. So in order to answer your question, I'm actually going to make a brand new project that will have a spirit of, that'll be all about testing functions. And so let's go ahead and make a brand new project. And in this class, you don't really make new projects very much. But let me say that whenever you guys want to experiment and expand your knowledge about the language, just make a new project that's 5 lines long. And that to me that's just good. That's just good thinking. So let's go down to the T's where we have kind of a test functions intro Java. And in that regard, let's close all this prior work down. I mean, it's good for the teacher to get expansive and do a bunch of work, but after a while, it's good to kind of bring it back to, its elastic beginning, at point 0. So let's make a little class. Let's call it the main part, and we'll call it actually allows you to put a main right in there, just in case you don't remember how to make a main, which is perfectly normal apparently. And then, I mean, I'm sure I would flub making a main, and I would hate to do that in front of, 1 million YouTubers, which is my average traffic per day is just like that. So, but let's do this. Let's say we've got a main. Now you realize that the main is itself a function, and its return type is void. So that's a bad starter. But why don't we set a string and L is equal to the results of a function called getString. Now the reason why this is kind of a good example is because we have a variable that we are defining and initializing kind of at the same time, which is fine. That's good practice. But we also make the value of this variable dependent upon the result of getString. So when you do this in Eclipse, it does something very valuable, which is to produce these little warnings. And it gives you lots of interesting and sometimes bewildering choices. But what I like for the beginners is to kind of just type something and then see where Eclipse takes you. It's a really great environment for learning. So create method getString. So that gets here. And I always take the comments away. I don't like comments to appear in the middle of my code. So I don't that's not good. It's better to just go over into the margin, right, where it remains valuable, but it's not overkill. And then I also like for beginners, I like for me to kind of go back to computer camp, where I was, coding BASIC in the 80s, as like for fun, and the way that all those brackets work is everything is very, it looks like this. It looks bracketed. It looks like a piece of geometry, like a geometric proof. It's very easy on the eyes. And really, you should be writing little solutions that are just plain dumb and easy. Strive for dumbness. Strive for simple-mindedness. There's really nothing wrong with that. It will create a much more resilient bedrock for your solutions. So the get string, let's say we have a string that we need to return. And right now it's null just so it'll compile. You know, when I build it, there are no errors. But in fact, we want to have a string that's called the result. And you know, we can put it inside of an empty quote. But then I think strategically we want to return the result. Does that make sense? So the move that I could make here is I could say result is equal to the character of A. And that's going to work. You know, it's all legal at this point. So if I were to say system.out.println, result was, you know, L, right? Because this result will become the value of L. You know, we'll set the value of L to this. So let's go ahead and run that. So you know, predictably, that's the result. So that's a good justification for the statement of return. Now, if I go ahead and eliminate that statement, everything is dependent upon, you know, compilation is dependent upon that statement. So it says, well, hey, you need to add a return statement. Or you can just return it to void, you know, where no return is necessary. And so that compiles. That's legal. But this will fail, and this whole strategy, you know, is dependent upon there being a string there and for there being a return. And that, to me, typifies the purpose and behavior of functions. That's valuable to us. Now, let me say this. Functions are both good to go when it comes to output as well as input. So what if we were to design another feature where it'd say integer I is equal to result of function. But I'm going to pass it L. Now, Eclipse is okay with that. So let's say we pass a string, get an int, right? And that's simple. So we could say, well, let's go ahead and create a method called the result of string. And let's kind of bundify it where we make it really dumb, really simple, right? And therefore fast and easier to think of, you know? So that integer is going to be what we return. So the first thing I want to do is I want to produce an integer that's going to be my result. And maybe there's an initialization value, but whatever result grows up to be, we're going to return it. And so we're going to take string as an input. And this is our input, a string. And we'll say, you know, if L dot, you know, equals, ignore case, A, we'll put that there for now, and we'll say, let's say, is equal to A, just for simplicity, just for illustration. And if L is equal to that value of initial, then perhaps result is equal to 1. Otherwise, my result is going to be equal to 3. Either way, result returns to the calling function. And we should also give a little bit of a system out. You can see that it's complaining about the fact that it's unused. And so we'll say integer value of I is now set to I. And so let's give that a little bit of a run. So you and I have kind of made some code pretty quickly. You know, look at that, it's 40 lines, and it should probably do something. your integer value is now of, what's the integer value of I. Integer is now set to 1. That's fine. So that gives us a special. Now, what if we created yet another fun mechanism here, which is called integer, and it's going to be called provide at random. And there's no input parameters, but what it does is it provides a random, and our result is going to be equal to, or we could actually just return, we could just say return our dot next int, maybe divided by 1 million. Or we'll just say that it's the next int. What I think I'd really like to do is to say is my result is going to be this. Now it's expecting for there to be a return, but what if my int, if my result is less than 1 billion, then my result, and I think we want to, when we say our result is equal to, I think we want to give it back, right? Why don't we just return the result for now? Because I would like to change it between these two results. And so what I wouldn't mind doing here is to actually run the provide random. And that's going to give us back an integer. And now I'm just kind of riffing right here. But if we could say ignores case, if the initial is this, and we could say if y is less than 1 billion, maybe then the result is 3. And we'll see some variation there. Now I'm going a little bit fast, so I may well make errors here, but it would be fun to see it jump up to 3. But I think that kind of exemplifies how functions are built to work, where they're constantly providing some arguments, such as here, such as that string, and then they're responsible for returning results there. Is that a pretty good discussion? Is that reasonable? Okay, so let's leave it at that.